Hello everyone, in this video we are going to experiment how temperature relates to the black body. A black body is a body that absorbs all electromagnetic radiation. It is called a black body because it absorbs all visible light and therefore will appear to be black. An example of an ideal black body is our star, the sun. It is near perfect black body, hence it does not reflect any light or allows it to transmit. This helps us understand better that the black body only depends on temperature. So in this lab, we are going to experiment the relationship between temperature and the black body curve. I will change around the parameters given and see the outcomes. This rainbow here is the different wavelengths of visible light, and the curve is the black body. Temperature is given to us in Kelvin, and the wavelengths are measured in micrometers or 1000 nanometers. So we have our density, spectral power density versus wavelength graph, and here we can see the value of intensity. And so depending on the temperature, I will test 4 different temperatures and see where that black body curve peak is at. We will begin with around 300 Kelvin. So for our first temperature, we are at 300 Kelvin, and the spectral density for that temperature is at around 3 × 10⁻⁵ megawatts per meter squared per micrometer, and the wavelength peak is at around 9659 nanometers, and the intensity is about 4.59 × 10⁻² watts per meter squared. The peak that we're seeing here is in the infrared light, so it's not absorbing any of the colors in the spectrum. The second temperature that we're looking at is at 3000 Kelvin, and the spectral power density for that is 3.40, and its wavelength is about 950. So looking at that here, we can see some of it absorbing the lights, but the peak is still in the infrared. But if we were looking at a star with this temperature, we would kind of see it as more red and yellow, since that's mostly what it's absorbing, but it is still in the infrared spectrum. So for our 6000 Kelvin temperature, we can see that the peak lays on the 483 nanometer wavelength, and that is seen in visible light and mostly seen as blue. And for our 10,000 Kelvin, we can see that the wavelength peak is at 290 nanometers, which is mostly seen in the UV, and only some of the visible light is absorbed here. So looking at all of this, we can come to the conclusion that as temperature increases, we can see that the peak wavelength decreases and the intensity we see here increases. And here we have all the different temperatures that we had tested in this lab and where they fell under the light spectrum. Here we have an example of 7 different bodies with different temperatures and emitted radiation. And this wraps up my presentation. Thank you for your time.